Let's see here. Oh, ooh, wow. The burn looks bad. Okay, it says connecting. Oh, it's on. Alright, so I found a spot. I like that view. That's nice. Halley's Comet by Francis Reddy from Astromedia, a publisher of Astronomy magazine. On the back here is a very nice chart that shows some things. Let's just go ahead and start with Halley's Comet. Perseus, Cassiopeia, Andromeda, Auriga, Gemini, Orion. Auriga, I think that's how you say that. This first little bit of text reads. I'm gonna do my trick where I read upside down. November 1st, 1985. Although still more than 100 million miles from Earth, Halley is easily visible as a diffuse spot in binoculars. It's not that easy to do, but I can read upside down. Oh, rain. December 15th, 1985. The comet is now bright enough to see without optical aid, but only from dark locations. From now to the end of January 1986, the comet is best placed for observers at mid-northern latitudes. And it's pointing here. This is January 1st. It's 86, Aquarius. And Pegasus. Aries, Pegasus. Aquarius. Yeah. February 6, 1986. Here looking like Capricorn? Aquarius? Pegasus, Aquarius, Capricorn. 86. Halley reaches perihelion, passing within 55 million miles, 89 million kilometers, of the sun's surface. Pisces Austrinus. Pisces Austrinus. Grus. Phoenix. Andromeda, Cassiopeia, Cygnus, Delphinius, Lyra, Aquila, Capricornus. It's been a beautiful day, all day. Why did the rain start just now? Yeah. Over the day. So, it's perihelion day. March 1st, 1986. The comet is now approaching Earth on the outbound leg of its orbit around the Sun. This marks the beginning of best viewing for observers in the southern hemisphere. By April, Halley is overhead at dawn as seen from mid-southern latitudes here in Capricorn. March 15th, 1986. March 13th. The European Space Agency's Giotto spacecraft flies past Halley's icy nucleus. Sagittarius, Scorpius, Centaurus. April 11th, 1986. The comet swings closest to Earth, passing only 39 million miles, 63 million kilometers away. We need a different unit of measure with double big numbers. April 15th, 1986. Long leg marks the beginning of the best year. Okay. April 15th, May 1st, January 1st, 1987. Okay, so May 1st, 1986 is here. April 1st, 1987. The comet lies about 425 million miles, 685 million kilometers from Earth, and is 1,300 times fainter than the faintest star visible to unaided eyes. January 1st, 1987. May 1st, 1987. Okay, so that's after he does this thing. September 1st, 1986, does this weird loopy thing on the map here. May 15th, 1986. Halley is again too faint to see without binoculars or a small telescope. Anyone with such equipment may be able to view the comet until late July. September, okay, so this says right there is September 1st, 1986. I wasn't conceived until Halloween of 1986 and born in July of 1987. So this book is older than me. It's us. Yeah. Introduction. Look at this. Look at this binding. I'm not too big of a fan of this kind of binding, but it works. Contents. Introduction. 1. What is a comet? 2. A history of Comet Halley. 6. 3. Cometary encounters. 18. 4. Looking for Halley's comet. 23. Index to maps. 35. Visiting the comet. 51. Further reading. 58. We'll see about the further reading too. But this being such an old book and about an event that happened before I was born, I went ahead and asked the AI about it, and I just copied what the AI said and I put it in a Substack post, and I think I sent it. If not, I will. Oh yeah. I didn't send it yet, but I'm all right. First edition, printed in Italy. Introduction. Nearly 3 generations have passed since it last appeared in our skies. In 1910, it swung around the sun, brushed Earth with its long tail, and shot out into the frozen depths of space. Sometime in 1948, its outward motion slowed, stopped, and reversed. The object started falling back toward the sun. 34 years later, astronomers at the Palomar Mountain Observatory found a faint, slow-moving dot on a photograph. It was a comet lying about as far from the sun as the distant planet Saturn. It was the comet, Halley's comet. heading for its 27th known return to the skies of Earth. So, 34 years later, astronomers, sometime in 1948, its outward motion slowed, stopped, and reversed. The object started falling back toward the sun. 34 years later, astronomers at the Palomar Mountain Observatory found a faint, slow-moving dot on a photograph. It was a comet lying about as far from the sun as the distant planet Saturn. It was the comet, Halley's Comet, heading for its 27th known return to the skies of Earth. Since the time between the comet's appearances roughly matches the average human lifespan, most of us will get only one chance to view Comet Halley. This book is designed to help you get the most out of the comet's 1985 to 1986 visit. Chapter 1 describes what today's astronomers know about comets. Chapter 2 discusses Comet Halley's many historical appearances and how it helps scientists, including Edmund Halley, whose name it bears. Separate comet fact separate comet fact from comet fancy. In Chapter 3, you'll find out whether a close encounter with a comet is something to worry about. It's not. Chapter 4 contains all the information you'll need to locate and observe Halley, including detailed maps for each of 3 latitudes: 55 degrees north, 40 degrees north, and 35 degrees south, and a cutout model of its orbit. Finally, in Chapter 5, you'll learn all about the international effort to send spacecraft past Halley's icy core. So, Chapter 4 contains all the information you'll need to locate and observe Halley, including detailed maps for each of 3 latitudes: 55 degrees north, 40 degrees north, and 35 degrees south, and a cutout model of its orbit. Finally, in Chapter 5, you'll learn all about the international effort to send spacecraft past Halley's icy core. The 1986 appearance of Halley's Comet won't be nearly as spectacular as its last return, which presents something of a challenge. With the maps in this book, clear skies, and an observing site far from city lights, you'll be able to follow the comet from its first rise to visibility in mid-December 1985 to its fade-out in mid-May 1986. As you watch the ephemeral comet course through the constellations, I hope that this book will help you become familiar with the stars too. After all, they are the permanent residents of the night sky. It's an acquaintance that can last a lifetime. Yes, absolutely memorize the star charts. Do it. Memorize them star charts. I wonder if I can. My pagan gods like some burr. What is a comet? Chapter 1. What is a comet? Comets signify a corruption of the air. They are signs of earthquakes, of wars, of changing kingdoms, great dearth of corn, yea, common death of man and beast. Leonard Digges, Prognostication Everlasting, 1576. Literally Renaissance era English. Brother, check it out. 'Tis glorious. An early woodcut shows a variety of comet forms. Right. Bet! Why I heard the door shut? Y'all be quiet, and y'all don't traipse in and out the house. Quit traipsing! I better quit hearing that door slam. Y'all go and play with your toys and be quiet. Alright! I better quit hearing that door slam. Oh, shut it. That's a very nice painting and a Barbie doll. Go play in your toy house. Go play in your toy house. Volleyball. Voila! Uh-uh. You didn't even peel it. Volleyball. Volleyball, be quiet. Shh. Can y'all please quit making noise? Quit. Shh. Oh. Making content is difficult, yeah. Many cultures regarded astronomical phenomenon. Events. It says events. Okay. Many cultures regarded astronomical events as omens of future occurrences on Earth. It was natural. Their very lives depended on recognizing the signs that told them when to plant crops and when to harvest. Out of necessity, our ancestors became intimately familiar with the slow and subtle rhythms of the sky. The sun's yearly march through the stars, the moon's ever-changing face, the complex motions of the planets. Comets didn't fit into this orderly scheme. They appeared suddenly and unpredictably, racing across the sky in a matter of weeks, trailing a diffuse saber-shaped tail stretching far across the heavens. The ghostly form of a bright comet could hardly be ignored. The sky was suddenly changed. A mysterious and frightful stranger was trespassing upon the firmament. Not surprisingly, early peoples viewed these awesome apparitions as harbingers of war and famine, ethereal weapons forged by gods. Among the first to offer a natural explanation for comets was the Greek philosopher Aristotle, whose opinion on the subject held sway among the enlightened for more than 1,000 years. For more than 1,000. Aristotle believed that comets were produced high in the atmosphere by pockets of slowly burning gas. I suppose he thought that the atmosphere extended all the way out. For him, comets were a meteorological phenomenon, a freak of weather, a sign foretelling wind and drought. This view wasn't seriously challenged until 1577, when careful measurements revealed a comet to be farther away than the moon. Since then, astronomers have tried to supplant the mystique of the comet with fact. In the process, however, they've managed to add some lore of their own. Many believe that comets represent tidbits of the original material from which the sun and planets formed. Some argue that collisions between comets and the Earth led to the catastrophic extinctions that wiped out thousands of plant and animal species throughout the history of our planet. A few even suggest that such collisions may have delivered to Earth some of the elements needed for life to begin. Well, I mean, if it was out there, it was down here already. Like the planets, comets are held by the sun's gravity and travel in egg-shaped or elliptical paths. While the orbits of the planets are very nearly circular ellipses, comets usually take far more eccentric routes. Earth's distance from the sun, for instance, changes by only a few million miles in the course of one complete orbit. But the elongated path of Halley's comet takes it to within 55 million miles of the sun and then carries it nearly 3,300 million miles away. 300 million. I swear, we need bigger units of measure for them big numbers. Million miles away. Beyond the orbit of the planet Neptune. I mean, measuring all these things in miles seems a bit like it's not like you're gonna walk out there, you know. Beyond the orbit of the planet Neptune! Exclamation point. Beyond the orbit of the planet Neptune! Astronomers. There's a little graph here. Old long period orbit, new short period orbit, the Sun and Jupiter. After a few passes near the giant planet Jupiter, a comet may become a permanent resident of the inner solar system. Oh, okay then. I suppose it hasn't been flying that close to Jupiter in the past. Yeah, there's a great app that shows you the orbits. Shout out to Daft Moon. Astronomers class comets by the length of time they take to circuit the sun. Those that complete an orbit once every 200 years or less are called short period or periodic comets, while those taking longer to circle the sun are dubbed long period comets. The comet with the shortest orbital period known, Encke, Encke, they named this comet Encke, makes one orbit every 3.3 years. It's a very close comet then, Encke. Halley, by far the brightest of the periodic comets, returns to the sun every 76 years. This is, however, an average, for Halley can take as long as 80 years between visits. The reason? The Sun isn't the only body controlling the orbit of a comet, although it's certainly the most important. It would be the biggest. I mean, the Sun is massive. I mean, even Jupiter is nowhere near as massive as the Sun. The Sun is truly enormous. And so each of these planets has their own gravitational well. So should the comet pass close to the gas giants, it would affect its orbit somehow. Some kind of mathematics is complicated, yeah. So Halley can take as long as 80 years between visits. The reason? The Sun isn't the only body controlling the orbit of a comet, although it's certainly the most important. When a comet passes near a planet, especially the giant planets Jupiter and Saturn, it receives a gravitational kick that can speed it up or slow it down. Either way, the event slightly alters the comet's path. In fact, all the comets we now call periodic once moved in long period tracks. A brush past one or more planets forced them into the tight orbits we observe today. I suppose this means that Enki has been around for a long, long time, and at Halley not so long, but still, we'll probably see how long it's been orbiting. By the mid 1700s, astronomers had the analytical tools needed to take these effects into account. Armed with the laws of motion and gravity revealed by Isaac Newton, scientists undertook the extremely complex computations required to determine how the planets perturbed comet orbits. Isaac Newton, alright, cool. But the results of even the most careful calculations were doomed to error, for the existence of two giant planets, Uranus and Neptune, were as yet unknown. The English astronomer William Herschel stumbled upon Uranus in 1781, and Neptune, the eighth planet of the solar system, wasn't found until 1846. While somewhat smaller than Jupiter and Saturn, Uranus and Neptune contain more than a dozen times the mass of Earth. More than a dozen times the mass of Earth. I could have printed that right here instead of going over to the other page. Anyway, I mean, maybe limited computer. I wonder how books were made in the 80s. February 9th, 1986. Mars, Jupiter, Earth, Saturn, Uranus, Neptune, and Halley's Comet. And this says 1948 down here. Man, there's some lovely photos in here. They are still considered planetary giants. Oh, yeah. That's a itty bitty airplane. Why is it so loud? It's a wonder the increase in fuel prices isn't making flights more expensive. Then again, maybe it is, and I just don't know. I don't check airline prices. I don't fly nowhere. I don't even drive nowhere. Gas and dust from the coma, swept back by sunlight, form a tail that can extend millions of miles. The coma, a thin, gaseous halo around the nucleus, can be hundreds of thousands of miles across. And go play. The solid part of a comet, its nucleus, can be up to 25 miles wide. Halley's is just 3 miles across. Shh. Got it. No, let me sit. Please. Shh. No, I told you I want to be quiet. I've been noisy all day. Now can be quiet. Hey. I did. Oh. All right. The solid part of a comet, its nucleus, can be up to 25 miles wide. Halley's is just 3 miles across. Comet Halley in 1835, second from left, and other 19th century comets. Shh. You've been noisy all day. What's the matter? What's the matter? Shh. Baby boy, let Mama read the book, please. Oh, said better. You tired? Go lay down. Go lay down. Good puppy. They are still considered planetary giants, and their influence on comet orbits can be far from negligible. Pluto, which was discovered in 1930, is too small to have much of an effect on anything but its own moon, Charon. Yet even when astronomers consider the gravitational effect of Uranus and Neptune, some comets simply didn't behave the way they were expected to. During the 19th century, Comet Encke seemed to be spiraling toward the Sun, its orbit shrinking by 17,000 miles each orbit, or about one part in 12,000. And Halley's comet teased observers of its 1910 approach by reaching its closest point to the Sun, called perihelion, 4 days later than predicted. A minute but important error. Such quirks indicated that some force other than gravity was acting on comets, and mounting evidence suggested that the comet itself was the culprit. The solution to this problem didn't come until the middle of this century. By this century, it means the 20th. And its arrival ushered in the modern era of cometary research. Prior to 1950, astronomers thought that the heart of a comet, the nucleus, consisted of a loose conglomeration of dust and gas, a flying sand bank, as some referred to it. But the very existence of the short period comets proved a nagging problem for proponents of this sand bank picture. Comet Halley had been observed for thousands of years. Yet how could this supposedly diffuse material have such a long lifespan? Comet Halley had been observed for thousands of years. Yet how could this supposedly diffuse material have such a long lifespan? Then in 1950, an astronomer named Fred Whipple at the Harvard College Observatory made a revolutionary proposition. Comets weren't sandbanks, they were snowballs. It says that with gusto. Whipple suggested that the nucleus was an icy conglomerate, a solid body a few miles across, made up of various frozen gases intermixed with dust. This dirty snowball model, which forms the basis of our current picture of comets, easily explained how these queer objects could modify their orbits. This dirty snowball model, which forms the basis of our current picture of comets, easily explained how these queer objects could modify their orbits. Here's the stroller. Now go play in the stroller. As a comet nears the sun, part of its icy surface heats up and evaporates. A thin halo of gas, called the coma, enshrouds the comet's solid nucleus. Sunlight striking this gas energizes its atoms and causes them to emit light. In essence, the same process that sets fluorescent lights and neon signs aglow. But the light of the sun and the tiny particles streaming from it sweep back the gassy coma to create a comet's long, wispy tail. While the evaporating ice carries away some of the dust mixed within it, much of this material remains behind to form a thin, dark crust. A comet nears the sun. As a comet nears the sun, Part of its icy surface heats up and evaporates. A thin halo of gas, called the coma, enshrouds the comet's solid nucleus. Sunlight striking this gas energizes its atoms and causes them to emit light. In essence, the same process that sets fluorescent lights and neon signs aglow. Both the light of the sun and the tiny particles streaming from it sweep back the gassy coma to create a comet's long, wispy tail. While the evaporating ice carries away some of the dust mixed within it, much of this material remains behind to form a thin, dark crust. Due to cracks and hills on the surface of the nucleus, some regions on the comet receive more light than others. Parts of the protective crust heat up and the ice beneath it starts turning into vapor. The crust gives way, and a plume of gas and dust shoots away from the nucleus. Such jets have been observed in many comets, including Halley. The outgoing stream of material pushes on the comet just like the exhaust of a rocket engine. This gives the comets the push they need to behave in ways even the most detailed account of planetary effects cannot predict. The success of the snowball model created another problem. If cometary activity starts with melting ice, then the short period comets cannot be more than a few 100,000 years old. Where did they come from? In 1950, the same year, Whipple transformed ideas about the nature of comets. A Dutch astronomer named Jan Oort. It says Jan, but he's Dutch, so it might be Jan. Jan Oort completed his study of the orbits of long-period comets. Each of the 19 comets he analyzed seemed to originate from a sun-centered spherical shell hundreds of times more distant than Pluto. Subsequent work has verified Oort's results. Comets, hundreds of millions of them, orbit in a deep, frozen realm so far from what we call the solar system that the sun shines as a mere pinpoint of light, the brightest star in the sky. The feeble gravity of passing stars, Oort found, is all it takes to dislodge a new comet from the comet cloud. The feeble gravity of passing stars, Oort found, is all it takes to dislodge a new comet from the comet cloud, and started on its long fall toward the sun. Once in the inner solar system, close encounters with the planets may slow a comet and force it into a tight orbit, or speed it up and kick it out of the solar system altogether. Astronomers have learned a lot about comets in the last few centuries, but we still don't have all the answers. We do know that comets are the most distant denizens of the solar system, perhaps even the leftovers of its formation. They are giant chunks of dirt-coated cosmic snow, transient and evanescent visitors to the realm of the planets. And while they are the most beautiful and striking members of the Sun's family, they remain the least understood. I have a theory. It's going to sound crazy, but it begins with as above, so below. For you see, if you were to look at a cell perhaps even a single-celled organism. Its cell wall can be compared to the Oort cloud, and the bits inside of it can be compared to the planets and the sun, like a cell nucleus. And then all of these other little things inside the mitochondria and all things like that. Maybe the sun's the mitochondria after all. Tis the powerhouse, ain't it? So perhaps the mitochondria of a cell can be compared to the sun in the solar system. And the cell membrane, the outer cell membrane, is compared to the Oort cloud, which makes the universe a multicellular organism. Don't you go in the house! Quit making excuses and stay outside so I can watch you. What are you doing in? No traipsing in and out the damn house. Now go play in the backyard. Oh, children. These are some very pretty photos. So, due to cracks and hills on the surface of the nucleus, some regions on the comet receive more light than others. Parts of the protective crust heat up, and the ice beneath it starts turning into vapor. The crust gives way, and a plume of gas and dust shoots away from the nucleus. Such jets have been observed in many comets, including Halley. The outgoing stream of material pushes on the comet just like the exhaust of a rocket engine. This gives comets the push they need to behave in ways even the most detailed account of planetary effects cannot predict. The success of the snowball model created another problem. If cometary activity starts with melting ice, then the short period comets cannot be more than a few 100,000 years old. Where did they come from? In 1950, the same year, Whipple transformed ideas about the nature of comets. A Dutch astronomer named Jan Oort completed his study of the orbits of long-period comets. Each of the 19 comets he analyzed seemed to originate from a sun-centered spherical shell hundreds of times more distant than Pluto. Subsequent work has verified Oort's results. Comets, hundreds of millions of them, orbit in a deep, frozen realm so far from what we call the solar system that the sun shines as a mere pinpoint of light, the brightest star in the sky. The feeble gravity of passing stars, Oort found, is all it takes to dislodge a new comet from the comet cloud and start it on its long fall toward the sun. Once in the inner solar system, close encounters with the planets may slow a comet and force it into a tight orbit, or speed it up and kick it out of the solar system altogether. Astronomers have learned a lot about comets in the last few centuries, but we still don't have all the answers. We do know that comets are the most distant denizens of the solar system, perhaps even the leftovers of its formation. They are giant chunks of dirt-coated cosmic snow, transient and evanescent visitors to the realm of the planets. What wordplay! That's magnificent. And while they are the most beautiful and striking members of the Sun's family, they remain the least understood. So, up here is Comet Bennett over the snow-covered Pyrenees. This reads, jets of gas and dust spiral away from the nucleus of Comet Bennett, which appeared in 1970. Run through a digital image processor, photographs of Halley in 1910 revealed the arc jets in its coma. Chapter 2. A History of Comet Halley. In the 16th century engraving Melancholia I, artist Albrecht Dürer set a brilliant, dynamic, but a very realistic comet into the background. These comets come from the Mawangdui Silk Book, which was recovered from a 900-year-old Chinese tomb. The book contains 29 drawings of comets, each of which is accompanied by the name of the comet and its astrological implications. The caption beneath the comet at right reads, "This is called Ganhui, war for years." The comet at left received the same prognostication. So here's Albert Dürer created this masterpiece. And this is from the Silk Book. No one knows how many times Halley's Comet has blazed across our skies. The earliest probable reference to it appears in the historical record, a Chinese book of observations compiled in the 1st century BC. A brief passage notes simply that a Hui Xing, a broom star, appeared for several weeks in the 7th year of Emperor Qian Shi Huang, 240 BC. The term broom star was used for a comet with a prominent tail. The ancient Chinese had a very sophisticated astrology. Since broom stars were believed to portend great change, the astrologers made detailed records of their size, shape, and motion through the sky. The accuracy of these observations was not matched in the West until the 15th century. Such records are an invaluable resource for astronomers interested in long-term studies of comets. Strangely, there are no records of Halley's return in 164 BC. Astronomers believe that the relative positions of Earth, Sun, and Comet created such a poor geometry that Halley could not be seen. It was, however, quit slamming the door! Okay. Strangely, there are no records of Halley's return in 164 BC. Astronomers believe that the relative positions of Earth, Sun, and Comet created such a poor geometry that Halley could not be seen. It was, however, well observed on its next return. In 86 BC, when Julius Caesar was a boy of 14, Halley's Comet terrified the citizens of Rome, the earliest unambiguous sighting of the comet. 86 BC. Julius and all the rest of the Romans saw it and were afraid. Halley has been blamed for all kinds of unpleasantries throughout the ages. When the Romans captured and destroyed Jerusalem in 70 AD, writers of the day recalled the comet that 4 years before had hung over the city like a huge sword. Halley was blamed for a plague in 141, as well as the invasion of Europe by the Turks in 1456. Some even associated the death of England's King Edward VII with Halley's return in 1910. 1910, the death of England's King Edward VII, Edwardian era. In 1910, my great-grandparents were out there in the marsh. hunting, fishing, trapping, farming. And not at all concerned with English kings because we're French people. My great-grandparents spoke only French, but we are Acadians. So this is very neat print on this page. So, when the Romans captured and destroyed Jerusalem in 70 AD, writers of the day recalled the comet that 4 years before had hung over the city like a huge sword. Halley was blamed for a plague in 141, as well as the invasion of Europe by the Turks in 1456. Some even associated the death of England's King Edward VII with Halley's return in 1910. Despite all this activity, however, there are relatively few drawings of comets that can be positively identified as renderings of Halley. Comet Halley appeared in 1145 while the monk Edwin was copying the Psalms from the earlier Utrecht Psalter. Copying the Psalms. Along the bottom of the page containing Psalm 5 in Edwin's Psalter is a sketch of a comet and a brief description. Some lovely illuminated work, but this like a bad Xerox copy of it. It's quite pretty though. I might copy it on my art paper. And everybody, Mia. Oh, um, it's very difficult to read this. So it's slightly blurry. Like a bad Xerox copy. So, right now, go ahead and Google Psalm 5 in Edwin's Psalter. Although this picture was inspired by the comet's 684 appearance, it wasn't actually executed until 1493. It appeared in Hartmann Schedl's Nuremberg Chronicles. The Bayeux Tapestry contains the earliest known contemporary portrait of the comet. Measuring almost 231 feet long by 20 inches wide, the tapestry was commissioned by Queen Matilda, wife of William of Normandy, to commemorate her husband's victory at the Battle of Hastings in 1066. Bon Dieu! In one scene, English men marvel at a stylized comet, while an aide informs Harold II of the bad omen. Work on the piece began in 1073 and took a decade to complete. I know how you feel. It's taken me a decade to finish my knitting slippers. Finish my knitting of my slippers. The tapestry now hangs in the town hall of Bayeux in Normandy. Comet Halley didn't do England's King Harold much good, but William, now surnamed the Conqueror, had nothing to complain about. Halley's apparition in 1301 also inspired an impressive work of art. A Florentine artist named Giotto di Bondone must have seen Halley's spectacular show. A few years later, Giotto Is that how you maybe it's not Giotto, maybe it's Giotto? So let's read that again. Because I heard that the GI in Italian is J. It's a J sound and not a Gia sound. So Comet Halley didn't do England's King Harold much good, but William, now surnamed the Conqueror, had nothing to complain of. Halley's apparition in 1301 also inspired an impressive work of art. A Florentine artist named Giotto di Bondone must have seen Halley's spectacular show. A few years later, Giotto was hired to decorate the interior of the Arena Chapel in Padua. Padua? Padua? Halley's appearance in 1066 was later viewed as a portent of doom for England's Harold II. The legend near the stylized comet reads, "They marvel at the star. Beneath the comet, an aid informs Harold of the omen." He covered the walls with tiers of paintings depicting the life of Christ. When he began adding the Star of Bethlehem to his fresco to adoration of the Magi, Giotto avoided using a traditional stylized star and painted a comet modeled after the one he himself had observed only a few years earlier. His version of Halley is not the geometrical comet of the Bayeux Tapestry, but a naturalistic portrait, a careful description of a comet's appearance. For this reason, some have called Giotto's painting the first scientific description of a comet. At the top here, it reads, "Isti mirant stella." So the word stella means star. So they marvel at the star. And that's Harold. Aristotle's view that comets were atmospheric in nature was beginning to weaken, but still held for two more returns of the comet. During Halley's swing past Earth in 1531, medieval Western astronomers discovered something their Chinese counterparts had known for 9 centuries. Comet tails always point away from the sun. They trail behind comets as they fall toward the sun and lead the way as they move back into space. In 1577, when another bright comet raced across the sky, astronomers throughout Europe attempted to determine its distance by measuring its diurnal parallax. Nod your head back and forth. The objects nearest to you seem to move a lot, while those farthest from you seem to move very little. The great Danish astronomer Tycho Brahe reasoned that the comet of 1577 would show a similar motion if it were very close to Earth. He measured the position of the comet with respect to the stars at different times during the night, when the comet was high in the sky and when it was low, and compared the results. The comet showed a motion much smaller than that of the moon, which meant that it lay beyond the moon and not in Earth's atmosphere. The scientific study of comets had begun. In 1607, when Halley again became visible, William Shakespeare had just completed Antony and Cleopatra and was working on Coriolanus. Johannes Kepler, a German mathematician and Tycho's protege, had just published his book on optics and was now trying to reconcile the theory of planetary motion with Tycho's detailed observations. So, The great Danish astronomer Tycho Brahe reasoned that the comet of 1577 would show a similar motion, a diurnal parallax, if it were very close to Earth. He measured the position of the comet with respect to the stars at different times during the night when the comet was high in the sky and when it was low, and compared the results, and found that it lay beyond the moon. Johannes Kepler, a German mathematician and Tycho's protege, had just published his book on optics and was now trying to reconcile the theory of planetary motion with Tycho's detailed observations. The orbit of the planet Mars proved particularly troublesome, but out of this research grew Kepler's famous laws of planetary motion. One of the laws states that the planets always move in elliptical orbits. Giotto di Bondone's Adoration of the Magi is one of a series of frescoes that decorates the interior of the Arena Chapel in Padua, Italy. The work was probably completed in 1304, 2 years after a spectacular visit from Halley's comet. Strangely, in his book about comets, Kepler expressed the belief that these bodies move through space in straight lines, irregularly speeding up and slowing down. Still, some of his ideas about comets seem very modern. For instance, he believed that comets glowed by reflecting sunlight, that their tails were formed by material driven away from their comet by sunlight, and that the comets were extremely numerous. When the comet next came around, the English physicist Isaac Newton was working on a theory that explained just why the planets obeyed Kepler's laws, and comets played an important role. By the middle of the 17th century, astronomers had found that the motion of a comet near the sun was best explained by assuming that it moved in a parabolic or open-ended orbit. A parabola. Newton Newton published a method of determining such an orbit from only 3 measurements of a comet's position. In 1682, Newton observed the comet with the young friend who helped him publish his great work, the Principia, and was also largely responsible for getting Newton interested in comets. Newton observed the comet with the young friend who helped him publish his great work, the Principia, and was also largely responsible for getting Newton interested in comets. The young man's name was Edmund Halley. Edmund Halley was a friend of Isaac Newton's. When Halley appeared in 1531, medieval Western astronomers finally realized that comet tails always point away from the sun, something the Chinese had known for at least 9 centuries. The Chinese astronomers, that is. Edmund Halley, and make it so. Let's read that without the build up and the and the name drop. There we go. In 1682, Newton observed a comet with Edmund Halley, who helped him publish his great work, The Principia. And Edmund Halley was also largely responsible for getting Newton interested in comets. Although most people know of Edmund Halley only in connection with the comet that bears his name, he made lasting contributions in other fields as well. Halley produced the first catalogue of stars for the southern hemisphere, prepared the first detailed mortality tables, which paved the way for the modern insurance industry. Experimented with diving bells and attempted underwater salvage operations, and looked for variations in the Earth's magnetic field. What did he find under the ocean? Or the water, anyway. Attempted underwater salvage operations. What did he uncover? What did they resurface there from underwater? What did they resurface? What did they really get? What did he go and find? Hope to know. So, experimented with diving bells and attempted underwater salvage operations, and looked for variations in the Earth's magnetic field. Halley had been interested in astronomy most of his life. He was 26 when he observed the bright comet of 1682. So in 1682, he and Newton observed the comet, and they have started calling it Halley's Comet after that. Halley's Comet. In 1695, so 82 to 95, in 1695, Halley began collecting the most accurate cometary observations in order to compare the orbits of many comets. He published his work in a book called Synopsis of Cometary Astronomy. A body moving solely as a result of the gravity of another body can follow just three kinds of orbits: hyperbolic, parabolic, or elliptical. The type of path taken depends on the speed of the object. No comet showed a velocity high enough to be in a hyperbolic orbit, but it was practically impossible to differentiate between a parabolic path and an elongated ellipse. If comets were found to move in truly elliptical orbits, then they would become visible periodically upon each return to the sun. Parabolic comets, on the other hand, would be one-time visitors. Because the open, like parabolic, hyperbolic, yeah, that open-ended. Let's see, which one was it? Alright, so Kepler's laws of planetary motion states that the planets move always in elliptical orbits. Okay, parabolic. Down here on this page, they thought the comets moved in a parabolic orbit. So, they become visible. Parabolic comets would be one-time visitors. Okay. If ever a new comet appears, Halley wrote in his synopsis, we may, by comparing the elements of its orbit, distinguish whether or not it could be one of those formerly observed and accordingly determine its period and predict its return. Because predicting things is really what it's always about. Predicting results was always the point of every kind of mancy, chiromancy, taromancy. We're trying to predict results. What's it called? Orthomancy? When you observe the movements of birds to find out stuff. So, looking over his table of orbits, Halley found several that seemed very similar and showed roughly the same period, around 75 years. Halley realized that the gravitational effects of the planets could alter the period from one orbit to the next. So the fact that the periods didn't precisely match was not a problem, because the mathematics of planetary motion are very, very complex. Many considerations incline me to believe the comet of 1531 observed by Appianus to have been the same as that described by Kepler in 1607, and which I again observed when it returned in 1682. However, this identity was supported by the fact that, in the summer of 1456, a comet was seen traveling retrograde, circling in the direction opposite to the planets between the Sun and the Earth, just as the other three comets had done. Halley argued that all four events were due to the same comet. Whence I would venture confidently to predict its return, namely in the year 1758. So 1758 is when he predicted its next return. It had come in 1456, in 1607, and in 1531. So 1456, 1531, 1607, 1758. The true nature of comets and their orbits was a hot topic in the 17th century. This illustration from Johann Hevelius' Cometographia, published in 1668, shows three scientists debating the issue. The man on the left holds that comets are very near the Earth, as Aristotle has suggested. The one on the right agrees with Kepler's view that the comets move in straight lines. The scientist in the center argues that comets move in parabolas, the view put forward by Hevelius himself. All right, I see. Johannes Hevelius, Cometographia. So there's a nice looking Greek building there with some instruments and people on top observing the sky. And these three men, one of them has this chart that shows comets inside of a circle around a central dot, which is probably. And then this other man holds a diagram showing a bunch of arrows radiating from the center of the circle. And then the fellow in the middle has a bunch of spirals and more complex math that looks like it makes more sense. However, it's neither of these. It's none of these three things. In Cometographia, Hevelius included a sketch of Comet Halley at its return in 1607, third from the top. And it just says Comet 1607. The others are just Comet 1647, Comet 1618. And there's something else right here, but I think it's in italics. So this one thinks it's in parabolas. And this one thinks straight lines. Comets moving. He thinks comets move in straight lines, and he thinks comets are near the Earth. Look, Aristotle was right about a lot of things, but not that. Why do I keep hearing the door slam? Halley realized that the gravitational effects of the planets could alter the period from one orbit to the next, so the fact that periods didn't precisely match was not a problem. Many considerations inclined me to believe the comet of 1531 observed by Appianus to have been the same as that described by Kepler in 1607. And 1607, and which I again observed when it returned in 1682, Halley wrote. This identity was supported by the fact that, in the summer of 1456, a comet was seen traveling retrograde, circling in the direction opposite to the planets. So, circling in the direction opposite to the planets. A comet was seen traveling retrograde between the Sun and Earth, just as the other three comets had done. Halley argued that all and there's so much noise out here. Many considerations incline me to believe the comet of 1531, observed by Appianus, to have been the same as that described by Kepler in 1607, and which I again observed when it returned in 1682. Halley wrote. This identity was supported by the fact that, in the summer of 1456, a comet was seen traveling retrograde, circling in the direction opposite to the planets between the Sun and Earth, just as the other three comets had done. Halley argued that all four events were due to the same comet, whence I would venture confidently to predict its return, namely in the year 1758. And if this occurs, there will be no further cause for doubt that the other comets ought to return also. There will be, if it returns, there will be no further cause for doubt that the other comets ought to return also. In a later edition of the synopsis, Halley found what appeared to be additional appearances of the periodic comet. He noted that if his prediction should come true, candid posterity will not refuse to acknowledge that this was first discovered by an Englishman. You gotta love it. So, Edmund Halley at age 30. He's 30. Isaac Newton's friend. So, these pages from Edmund Halley's notebook contain his original observations of the comet that bears his name. They could have printed it a bit bigger, huh? It's a teeny tiny and you can't read it. There's a very faint, diagram up here. And a bunch of illegible notes. Hyperbola, parabola, ellipse. This is a diagram here. Ellipses, parabolas, and hyperbolas are all Ellipses, parabolas, and hyperbolas are all shapes formed by slicing through a cone at various angles. Conic sections. It's hard to tell the difference between orbits shaped like the conic sections, especially very near the sun, where an orbiting comet would be bright enough to be seen from Earth. Baby, you need to go take a nap. Quit climbing on things. Go take a nap. So, Halley's orbit for the comet of 1680, as it appeared in Newton's Principia. Linear Nodorum orbis cometus, axis orbitus, and some dates and some. I'm not sure exactly how to interpret his drawing, huh? There would be no further cause for doubt that the other comets ought to return also. In a later edition of the synopsis, Halley found what appeared to be additional appearances of the periodic comet. He noted that if his prediction should come true, candid posterity will not refuse to acknowledge that this was first discovered by an Englishman. Soon after Halley's death in 1742, several French astronomers independently took up where he left off and computed the comet's path in greater detail, even including the complex planetary perturbations due to Jupiter and Saturn. All of the computing was, of course, done by hand, so the task was enormous. Their calculations indicated that the comet would reach perihelion on November 1758. So what was his? He thought it would come back. Yeah. Okay. Yeah, he thought it would come back in 1758. But they figured out it's in November. He thinks that's funny. I'm trying to swat him with the broom. Broom dodger. He's such a strange boy. On December 25th, so They figured that it would reach perihelion in November 1758. On December 25th, 1758, a German amateur astronomer named Johann Palitsch, ZSCH, Palitsch, On December 25th, 1758, a German amateur astronomer named Johann Palitsch became the first. Johann Palitsch. Stop shrieking, you little crot. Shh. Come on. Be quiet. Okay, so on December 25th, 1758, a German amateur astronomer named Johann Palitsch became the first to spot the comet. Calculations based on the new positions revealed that the predicted date of perihelion was off by only 32 days. He spotted the comet in December, at the end of December, instead of November. The predicted date of perihelion was off by only 32 days, given that they were figuring this out in 1742 by analog mathematics. 1742. Halley's death. And then French astronomers, and it doesn't name them. It just goes on and names this German one. Who are the French astronomers? Hey, how come they're left out? Oh. Johann Palitsch. So, he became the first to spot the comet. Calculations based on the new positions revealed that the predicted date of perihelion was off by only 32 days. This event marked the first successful prediction of a comet's return, and the comet has been called Halley's ever since. After the comet's 1759 appearance, an unofficial contest began as astronomers worked on predictions for the 1835 return. So after the comet's 1759 appearance, so it's like it says December 25th in the previous line, so apparently near January it appeared. It appeared again, probably going retrograde. Perhaps an unofficial contest began as astronomers worked on predictions for the 1835 return. Think about that. Contest between astronomers to figure out when the comet's coming back by doing math by hand. Okay, enter our contest. We're going to do a whole lot of math to figure out when this comet's coming back. The goal? An accurate prediction for the perihelion date that included the gravitational effects of the 6 known planets. Of course, that labor was in vain. William Herschel's discovery of the planet Uranus on March 13th, 1781. So, forced them to begin the tedious work all over again. So it appeared in 1759. They're going to try and predict it. Come back around 1835. So 1759 to 1781. In 1781, William Herschel discovered the planet Uranus on March 13th, 1781. Forced them to begin the tedious work all over again. Uranus was a significant effect on Halley's orbit because the comet spends more time at the far end of its path, in the vicinity of Uranus. So Uranus has a significant effect on Halley's orbit because the comet spends more time at the far end of its path in the vicinity of Uranus than at any other point. After allowing for Uranus' gravitational effects, new predictions indicated that the comet would reach its closest point to the Sun around November 13th. So again, they're predicting November, but it came. See, they predicted before that it would come in November in 1758, but then in December 25th, 1758, Palaiseach spotted it, and then in 1759, an unofficial contest began to predict 1835. But then in 1781, William Herschel discovered Uranus, and the tedious work began all over again of doing math by hand. To figure out when the comet's coming back. Analog math. After allowing for Uranus' gravitational effects, new predictions indicated that the comet would reach its closest point to the Sun around November 13th, 1835. Halley was first glimpsed in early August. The actual perihelion date turned out to be November 16th. So they predicted the 13th and they got the 16th. That's not bad. That's some impressive math. Analog math. Impressive. Very impressive analog math. An alarm to Europe by a late prodigious comet seen November and December 1680, with a predictive discourse together with some preceding and some succeeding causes of its sad effects to the east and northeastern parts of the world, namely England, Scotland, Ireland, France, Spain, Holland, Germany, Italy, and many other places. Holland. The Netherlands is what they called Holland back then. Like Netherlands and Belgium, right? By John Hill, physician and astrologer. The form of the comet with its blaze or stream as it was seen December the 24th, anno 1680, in the evening. Europe, Terra. London, printed by H. Brugeau for William Thackeray at the Angel in Duck Lane, 8th of January, 1680-81. So the actual perihelion date turned out to be November 16th. While many people feared the comet of 1680, Edmund Halley managed to calculate its orbit, a first in cometary astronomy. So 1680, and he died in 1742, and then came back November 16th, 1835. All right, complex math. Alrighty. Let's see what we got on this. There's Star Trek. The German astronomer Otto Struve made this detailed sketch of Halley's appearance through a telescope in 1835. That's a sketch by a German, Otto Struve. Otto Struve, 1835. And here is some text in German. In January 1759, the Hamburgisches Magazin announced Johann Palitzsch's recovery of Halley's comet. It says recovery. Edmund Halley's bold prediction had come true. And here is some very old text in some very old German. After the 1835 success, they were only a couple days off, and they didn't even know about Neptune nor Pluto. They just found out about Uranus. After the 1835 success, astronomers began calculating backward. The discovery of ancient Chinese comet catalogs enabled astronomers to compare the dates of historical comet sightings with the results of their backward calculations. Interestingly, ancient Chinese observations are still used to help constrain modern computations. In stepping back through Halley's orbit, astronomers found that the comet passed extremely close to Earth, within 4 million miles, in the year 837. Its tail stretched more than halfway across the sky at closest approach. Although Earth isn't very massive, the comet came close enough to us for our gravity to significantly alter its path. In order to step the calculations further back in time, astronomers needed reliable sightings of the comet. So in the year 837, the Chinese had recorded it. So like you were saying on that other page, like in some of the instances where it should have been spotted, it might have just been at a bad angle. Although the predicted date of Halley's next return to perihelion wasn't until April 16th, 1910, searches began in the winter of 1908. For the first time, photography was used. Theoreticians had determined an orbit more precise than any previous, largely because they had figured in perturbations from the planet Neptune, discovered in 1846. Still, the comet arrived at perihelion 3 days later than predicted. Astronomers then knew that something other than gravity was affecting comets, but it took until the middle of this century before astronomers understood the icy nature of these objects and the sudden eruptions of gas that can change their orbits. So, the middle of the 20th century is what it means there. Middle of the 20th century. Our planet actually passed through part of Halley's tail in May 1910. Doomsayers were predicting the end of the world. Once poisonous cyanogen was found in the gases making up the comet's tail. Oh, oh no. Oh no. What did the media do? Protective inhalers and comet pills were popular, if useless items. Oh shit. Oh shit, this one's useless now too. Comet pills. Comet pills. Oh, mon Dieu. Maudit diable. Protective inhalers and comet pills were popular, if useless, items. Once poisonous cyanogen gases was found in the gases making up the comet's tail, and many people went to great lengths to seal up their houses. We couldn't do that with our cage or shotgun houses, though, where my great grandparents lived in 1910, and my grandparents weren't born until the 1920s. My grandpa in 1924, and my grandma in 1928. So ain't no way my great grandparents could, like, listen, they only spoke French and they couldn't read, so ain't no way they fell for this crap. They were just out there hunting and fishing like always. My great grandparents couldn't read, and nobody they knew could read either. And they all spoke French. So little material makes up a comet tail that even the deadliest gas would have no effect. If Earth passed through the densest part of a comet tail, there would only be one atom of comet gas for every 10,000 million atoms of our atmosphere. And then it would just stay up there in the atmosphere, probably. It wouldn't even get down here. A New York Times headline of May 16th, 1910, gave a realistic picture of Earth's passage through the tail of Comet Halley. Scarfed in a filmy bit of it will whirl on in our dance through space, unharmed and, most of us, unheeding. To the eye, a comet's tail looks like a smooth band of diffuse light. The rich structure of comet tails was largely unsuspected by astronomers. Until the introduction of photography. In 1910, photographs of Halley revealed fine details. Outward moving knots, streamers, and discarded tail fragments that astronomers could follow night after night. Photographs of Halley revealed fine details, outward moving knots, streamers, and discarded tail fragments that astronomers could follow night after night. Established returns of Halley's Comet. No, hey, there's a lot of room back there by the stroller. Voila. Voila! Need a quick break. Established returns of Halley's Comet. Date of perihelion, March 30th, year 239 BC. October 5th, 163 BC. August 2nd, 86 BC. October 5th, 11 BC. January 26th, 66 AD. March 20th, 141 AD. January 26th, 66 AD. Interesting. May 17th, 218 AD. April 20th, 295 AD. February 16th, 374. June 24th, 451. September 25th, 530. March 13th, 607. September 28th, 684. May 22nd, 760. February 27th, 837. July 9th, 1912. Or 912, not 1912. Silly mistake. So, July 9th, 912 AD. September 9th, 989. March 23rd, 1066. April 22nd, 1145. October 1st, 1222. October 23rd, 1301. November 9th, 1378. June 9th, 1456. August 25th, 1531. October 27th, 1607. September 15th, 1682. March 13th, 1759. November 16th, 1835. April 20th, 1910. February 9th, 1986. And I asked the Google AI if I had read this book just like a few years ago, I'd have just said that I Googled it and found out when it's coming back. If I had just like read this book just like 5 years ago, I probably already had it. We have a lot of books, so like if I had read this book 5 years ago, I'd have been like said I Googled it and found out it's coming back in 2060 something. 2067, something like that. Or is it 2035, something like that? It's not coming back for quite a while. I feel like I'll be old and my parents won't be alive no more. My dad was born in 63. And he's now 63 years old. Yeah. Miss you, Pappy. So, going back a little ways, let's see again about. So yeah, Harold and the Conqueror. So 1607. All right here, October 27th, 1607. That's Shakespeare's viewing. And then 1682. The 1682 viewing is the one. Okay. Yes, when Newton observed it. We got a little dot on the 6 here. September 15th, 1682. That is when Newton and his buddy Halley observed it. They figured out all of this after figuring it out there. Shedding side combs and hairpins, the comet looks lost among the advertisements using its name to sell a product. Halley was used to pitch perfume, light bulbs, and even soap. Lapada Phillips. Halley's comet brightens the skies once in 75 years, but every day the Earth is brightened by E. Morganson's Sapolio. Works without waste, cleans, scours, polishes. The chief attraction of the coffee world. Newman's pure high-grade coffee leaves a delightful lingering aftertaste. Halley's Comet Rag by Harry J. Lincoln, composer of Rag Dag, Poverty, A Southern Dream, Waltzes, Fire Drill, March Two-Step, Playmates, March Two-Step, Vandersloot Music Pub, Williamsport, Pennsylvania. Oh, yes, the shameless commercialization of an event. Okay, nothing new under the sun, and the more things change, the more they stay the same. So, the Halley's Comet Rag was one of the musical products of the 1910s comet craze. So while my great-grandparents were just, hunting and trapping. See, go back once more and look at it again, and it was April the 20th, 1910. It was his birthday. He was born in 1889. April the 20th, 1889. Adolf Hitler was born. So in 1910, he was a young man, old enough to have seen it. His mother was probably still alive. As for my great grandparents, it's unclear. I'm gonna have to check to see when their birthdays were. This time around, early searches for Comet Halley paid off. On October 16th, 1982, yeah, shh. On October 16th, 1982, American astronomers David Jewett and Edward Danielson of the California Institute of Technology attached a super-sensitive electronic camera to the 200-inch telescope at Palomar Mountain Observatory and managed to get an image of Halley. It was nothing more than a tiny dot, a bare nucleus which had yet to exude a sheet of gas and dust. At the time of recovery, Halley was over 1,000 million miles from the sun. 1,000 million miles from the sun. It says 1,000 million. About the distance of the planet Saturn, and over 3 years from perihelion. Never before have astronomers had the opportunity to study an infalling comet so far from the sun, watching for the first signs of a developing coma and monitoring its brightness for regular variations, the telltale sign of rotation. They have found that Halley's nucleus takes about an Earth day to spin once on its axis. Astronomers all over the world have planned an observational assault on Halley that includes telescopic observations from Earth. Shh. Astronomers all over the world have planned an observational assault on Halley that includes telescopic observations from Earth and from orbit, special Comet Halley missions by the U.S. Space Shuttle, and even a multinational effort to fly space probes close to the comet. Halley's regular appearances have punctuated history for at least 22 centuries, and probably many more. As the first comet whose return was successfully predicted, Halley showed that comets were members of the solar system and subject to the gravitational influence of the sun and planets. With each return, Halley has greatly enhanced our understanding of comets. It's fitting, then, that in 1986, scientists plan on making Halley the most extensively studied comet in history. The first image of the inbound comet in 75 years, taken through the 200-inch Palomar telescope in October 1982. This was state-of-the-art cutting-edge technology of the day. And that's the end of chapter 2. We'll pick up chapter 3, Cometary Encounters, next time. Thank you for watching.